So here we notice that these terms are in a geometric progression, 1/4, and this is 1/4 square, 1/4 cube. So one common technique is to multiply by that common ratio, which is just 1/4. And so if this is the sum, I'll multiply both sides of that sum with 1/4. And what that will do is you will get higher powers, the next higher powers, and then generally we'll subtract. And that's how you get the formula for the geometric sequences as well. So that's what I'll do here. And sometimes it works, sometimes it doesn't, but that's usually where I would start with these types of questions. So this would become 1/4 cube. And then we have finally, now you just have to write it far enough that you can see the pattern. And what I'll do is I will subtract this the bottom equation from the top. So we'll get s minus 1/4 s, and then 1 plus, and then since these two terms have the same 1/4, I'll factor that out and then subtract. So of course I'll do the same in the exam because I'm trying to save time by not having to write all these terms, but I need to write enough so I can see the pattern. And then I'll match this term with that. So when I'm subtracting, again, I'll factor out 1/4 square, and then I'll have plus 1/9 minus 1 minus 1/3. So you'll see certain terms will drop out and you'll start to see a pattern. And then finally we have this 4th cube. So it would be that whole thing minus this. I need to include the 1 as well. Minus 1. And if you try to observe the pattern here, this drops out. So that just becomes 1/3 times 1/4. Here, these two terms would drop out, so it would become 1/9 times 1/4 square. And then here, these three terms, so I get 127 4 cube, and we can expect the next would be 181 and 4 to the 4th. So question is, do we have a pattern here? And you'll see that yes, it is 1 plus 3 times 4 to the power of 1, and this is 3 square, so that becomes 3 times 4 square. And then same thing here, 3 times 4 cube, because this is 3 cube. So you just have to write it far enough that it's very clear to you what's happening. And here we end up with 3/4 s. And we notice this is just a geometric sequence, and we know the formula for s, where r is the common ratio, where r is less than 1, it would be 1 over 1 minus r. So here r is 1/12. So this sum here, and note here that sum is different from here. This is in general for an infinite geometric sequence. So it would be 1 minus 1/12, which is 1 over 11 over 12, or 12 over 11. And now we can come up with an expression for s, which would be 4 times 12, 11, 3, and that becomes 16 over 11, which is answer choice B. So this is one way to do it. The second approach is you can actually just compute this out. So I would do it this way. So this is 4/3 times 1/4. So it's 1 plus 0.333. And then you can just either use calculator directly, or if you're doing it by adding the fractions, would be 9 over 9, 3 over 9, plus 1 over 9 times 1/16. So that's 13 over 9 times 16. And I'll do the calculator for this part, because you can just use the calculator for these simpler calculations. So you'll see it kind of drops to 0.0902. And if I add that to the remaining terms, so far I'm at 1.4236. I can do one more step just to see how much it's dropping. So here I'll do 27 over 27, 9 over over 27, 3 over 27 plus 1 over 27 times 164. So that's 36, 39, 40, 40 over 27. Again, at this point, I'll use the calculator. And I get 0.0231. So you see it's kind of dropping, and if I add it to this 1.4236, I get, at least for the first 4 terms, 1.446. So then we can kind of just compute these out and see which one is closest. So you'll see this is, choice A is 1.875, quite far. But I'll first compute all of these. And of course, right now we know the answer. So that's 1.4545. So pretty close. And then 27 over 12. Again, that's actually greater than 2. So you don't need to even compute it. And then finally, 15 over 13. That looks like a good candidate. But as you'll note, that's 1.15. So that one you can even eliminate just by the first 2 terms. So you can just take this approach, and you can see you can also get away with your answer in this question. Of course, if this was a type in the answer question, then you will not have that option, and it would just be hard. So absolutely make sure that you can kind of approach with these types of manipulations, because that is kind of common on the CAT with these types of questions. So to summarize, the answer is B.